I'm going to go ahead and get started with some announcements and introduction for us, and then we can get started. Hi, everyone, and thank you for joining us for PowerFlex's webinar today, EV charging hardware. What type of charger should I use for my site? I'm Emily Lau, Marketing and Communications Manager at PowerFlex, and the host for today. Our speaker is Balthazar Lechene, PowerFlex's Associate Director of Hardware Product Management. Balthazar joined PowerFlex over the summer of 2022 to lead hardware product management. He had previously spent several years at SunPower as a product manager for the residential segment. A graduate from École Polytechnique and Grenoble University PhD program, he started his career doing scientific research on novel printed energy devices. He then co-founded a startup, led it through its first round of funding, and fell in love with product management. At PowerFlex, Balthazar oversees the EV charger portfolio and its integration within PowerFlex's leading-edge software platform. This webinar will be recorded for PowerFlex's proprietary use, and we will make it available to participants afterwards. The presentation will last approximately 30-ish minutes, leaving 15 at the end for attendee questions. The question function has been enabled for participants to submit questions there and throughout the presentation, and Balthazar will address those during the latter Q&A portion. So thank you to everyone for joining us, and without further ado, I'm going to hand it over to Balthazar.
Thank you for the introduction, Emily. Thank you everyone for attending. It's a pleasure to talk with you today. As Emily mentioned, and the title of the webinar is "What type of charger should I use for my site?" And more broadly, we're going to cover basics of EV chargings, what are the components of an EV charger installation, and then really dive into how you customize your EV charger solution, not only what type of charger, but also how many. And then we look at how you lower your installation and operating costs, and then give a couple of examples, and then we'll have time for Q&A. A brief word about PowerFlex to start with. We are a national provider of clean energy solution. We serve primarily C&I customers. And what we do is we provide a turnkey solution for anyone who is looking to install solar, storage, or EV charging at their facility. And we also provide a very strong backbone for asset management so that your newly installed clean energy products function optimally throughout their lifetime. We are a subsidiary of EDF Renewables, with Manulife being a minority investor in the company. And we've been around in different forms for about 35 years on the solar side, and more recently 5 to 6 years on the EV charging side. So overall, to date, we've installed more than 9,500 EV charging stations. We have the fourth largest network of public EV chargers in the US. We've also installed 360 megawatts of commercial solar and 46 megawatt hours of commercial storage. And in 2022, we were #2 in the nation in terms of solar installation at the commercial scale, very, very close of being #1. So this year we're aspire of being #1 on that front. As I mentioned, we provide really a turnkey solution. So that means that we have all the expertise in-house to help you and cover your needs throughout the lifetime of a project, be it from project development, installation, procurement, and then operations of your asset management, optimization, and then even the marketing and public relations side, where we can help you promote your clean energy investment. We are well served to, we are well equipped to serve a variety of customers, and our customer profile is very varied. As you can see, we work with local governments, real estate agents, a variety of workplaces like educational institutions, nonprofit, research, or regular workplaces. And we also like to work with big companies like car manufacturers or fleet managers like DHL. So all of that to say that we have what it takes to install and serve your needs when it comes to clean energy solution, and we'd be more than happy to work with you. So if at the end of this webinar you are interested, please reach out and we'll be happy to work with you. Jumping into the meat of the topic, let's talk about EV charging basics. there are three types of EV chargers. One that's not even represented here is the level 1, which is basically what's called trickle charge, which you plug into a regular outlet and connect to your car. That's what you can do at home if you want, but that's really not applicable to commercial installations. On commercial installations, you have two types of EV chargers, level 2 chargers and DC fast chargers. Level 2 chargers typically have 3 to 20 kilowatt, provide 3 to 20 kilowatt of power, and that's enough power to charge a car that has a 200-mile range in about 8 hours. And you can recognize these chargers, A, because they're usually small, and B, because their connector is the J1772 plug, which is pictured here. So 5 wires in a circle. And on the other hand, DC fast chargers are much bigger in size. They provide 25 to 360 kilowatt of power, even more if you look at the really like newer models that are announced. And that's enough power to achieve a full charge of a vehicle within an hour. And their connector is much bigger. This is a CCS connector, which is what the US is standardizing around. So it's the same J1772 plug on top, and then you have 2 big wires at the bottom. There's another type of DC fast charger plug called CHAdeMO, but this one is getting phased out in the US. In practice, the difference between a level 2 and a DC fast charger is where does the conversion of AC electricity to DC electricity happens. So grid provides AC electricity, AC is for alternating current, and the battery of the car is in direct current or DC. So at some point in the chain of transmission, you need to convert that. With L2 chargers, the charger provides AC electricity to the car, and then the onboard inverter of the car does the conversion from AC to DC for the battery. Whereas in the case of DC fast chargers, the inverter is in the charger, and the charger sends DC electricity straight into the car. And so the big difference is that in the case of level 2s, you are limited in terms of power by the amount of power that the onboard inverter of the car can accommodate. And because these cars are always optimized for weight and size, those tend to be limited. Whereas with DC fast chargers, the sky is the limit when it comes to the size of the inverter. And so really the only limit is how much energy at the time can the battery absorb. And so that's why DC fast chargers are much higher in power than level 2 chargers. And you can see that when you open them. So here is a typical level 2 charger. That's a PowerFlex model. That's the outside of the charger. Typically, an L2 charger is going to be about 1 foot by 1 foot with a ½ a foot of depth. And if you open the charger, you'll see a fairly simple electrical circuit. You have energy coming in from the grid. This is where the energy comes out and goes in the cable that goes to the car. And then what you have on the board is pretty simple. You have switches, which is to turn the power on and off, CTs that measure the current, and then a few PCBs that provide the smart and the connectivity. So we have like a Bluetooth, LTE, and then the screen function here. Typically, level 2 is going to accept 208 to 240 volt of power, of input voltage. And the typical power is between 32 to 80 amp. So that means that you need breaker size between 40 and 100 amp. On the other hand, DC fast chargers are much bigger. Typically, they are the size of a fridge, and they can weigh between 100 and 3,000 pounds or more, sometimes in multiple units. And if you open them, what you see is that you have most of the space is taken by the onboard inverter, so the AC to DC conversion unit. And then you need a lot of cooling as well, because those units run through a lot of power. So you have a lot of electrical heating. And then you have, of course, computing and communication as well. And in terms of input power, they typically take 480 volt input, and then whatever the amount of amperage is needed to reach the full power that they deliver. So because of the difference of size, there's a difference of installation. Typically, L2s are mounted either on a pedestal or a wall mount. If you have a solar carport, you can also mount them on the piles of the carport, and that's convenient. That's killing 2 birds with the same stone. And if you really want to pack your parking lot and you have thin enough chargers, you can even do 4 on a single pedestal. What's not shown here is that the other piece of the installation is a cable management, and that's something that's sometimes overlooked, but need to be thought through. It can be as simple as looping the cable around the charger or around the holster if you have an appropriate holster. And otherwise, you can look at retractors. Retractors have some issues. Usually they break. No one yet has cracked the perfect retractor solution. Or what we're a really big fan of at PowerFlex is high point anchor. The idea is that you you run the cable that goes to the car 7 or 8 feet to the ground. And because of, you can achieve pretty much the same reach when it comes to plugging into the car, but instead, when not in use, instead of being coiled on the ground and having the potential of being run over, your cable basically comes back next to the wall and you prevent waste you prevent unfortunate events of cars rolling onto your cable and breaking them. On the DC fast charger side, the smaller units that are in the 20 to 25 kilowatt range can still be wall mounted, but very quickly they become too big for that. So typically you see all-in-one cabinets like this one. And then for the very big units, you even see multiple cabinets and dispensers. Usually you have a very big power cabinet somewhere and then multiple dispensers for each parking spot. So a good EV charging provider is going to provide you with a wide variety of charging ranges. And at PowerFlex, we pride ourselves of being top-notch when it comes to being good energy EV charging providers. So we have several level 2 chargers in our stock, ranging from 7 kilowatt all the way to 19 kilowatt. And then DC fast chargers, same thing. You want to rerun the gamut between lower energy, around 30 or 50 kilowatt, all the way to 100 or even 180 kilowatt to rematch the need of our customers. And that's what we're going to cover next. Before jumping there, though, a brief overview of what else about EV chargers goes into an EV charging installation. So you need the EV chargers, obviously, but then there's a lot of equipment that comes around it. First, there is a controller box, usually, that is needed to provide the communication in a reliable way. At PowerFlex, one of our key differentiators is that we do adaptive load management on a very high scale. And we'll talk about that a bit later, but that's really what makes us unique. And in our case, we want the magic to happen on site. So we have a box that contains the load management controller. But in any case, all installations will also require additional electrical panels. You want dedicated electrical panels for your EV chargers. You also need to account for cable runs. That requires trenching, and that can become fairly expensive depending on the site that you have, because not only is copper fairly expensive, but also trenching is a fairly involved act where you need to dig holes and then you need to resurface your area or parking, and so that there is a significant cost there. If you install big enough EV charging installations, you're likely going to increase your needs in terms of overall service. So you'll probably need to install additional transformers. And then all of this new equipment will usually require concrete pads and bollards to prevent cars from running them over. So on the right here, you have a typical installation. On the left, you have DC fast charger spots. We have 1, 2, 3, 4, 5, 6 DC fast chargers. And then we have 20 level 2 chargers. Those chargers are installed on the carport. So what you see here are carport piles. And so the plan set calls for the chargers, bollards to protect the DCFCs, and then concrete pads, and then your electrical panel or main switchboard, depending on the amount of power that you need. And then here in this case, you have a transformer from PG&E that provides the power for the site. So, when we talk about EV charging installation, the EV chargers are the main piece, but there is actually a fair amount of elements that go into the site overall. The other piece that's important to take into account is that all hardware needs good software, especially when it comes to managing EV charging sites. You want a software platform that allows you to really understand what's happening on your site, how much electricity you're using, and something that allows you to control your drivers or manage your drivers rather. So that means, being able to either build them or give access to them, prevent access to people you don't want. And you also want something that's as user-friendly as possible, as much for the drivers as for the site manager. And at PowerFlex, we pride ourselves of having a very leading edge platform called Access. So that provides you with real-time insight of EV charging, all the features you would want in order to control your site. And the additional thing that makes us really unique is that since we have both an EV charging expertise, but also solar and storage expertise, Access actually allows you to optimize the use of all those assets together, and that really puts us apart from the rest of the competition. All right, so let's get into the answering the question of this that are the title of the seminar. How do you customize your EV charging solution? A quick note, EVSC is a standard term for EV charger. It stands for EV, electric vehicle supply equipment. So if you see EVSC, just read EV charger is the same thing. So the first thing to understand is that different cars have different needs. Those are 4 examples here of typical passenger cars. You have plug-in hybrids that have very small batteries that give them 10 to 30 miles of electric range. And after that, the gas engine kicks in. So the range anxiety for these cars is low, but they will want to plug in every time they can, so they maximize the amount of electric miles that they drive. Then you have small battery EVs that have small batteries, and that results in a small range, like 60 to 120 miles. These cars, they will want to charge as well every time they park as much as possible. And this will be critical because the anxiety range will be high. Like people will be really upset if they don't get enough energy when they need their car. And then you move to the larger vehicles, like typical passenger vehicles like Teslas or electric SUVs that are becoming more and more common. Here, the range goes to above 200 miles. So the electrical, so the range anxiety gets lower. The onboard inverters of those cars get bigger as the batteries get bigger. And what that means is that these cars will plug in less often, but when they plug, the chances are that their energy per session is going to be much bigger, and that will have an impact on your energy bill on your site at the end of the month. So that's something to take into account. And they will require higher power EV chargers. So you really want to match the power of your EV chargers with the type of vehicles that you expect at your facility. If you were looking at fleet and commercial vehicles, it's the same mindset with different use cases. So here are 3 different use cases. First, delivery vehicles. Typically, they have battery in the size of 30 to 110 kilowatt hours. That gives them ranges between 50 and 150 miles. Usually, they have predictable routes, and they come back to the depot every night. So they charge overnight. And so for those use cases, L2, a powerful level 2 is going to be enough. On the other hand, if you look at buses or trucks, you're looking at much bigger batteries for ranges that are in the 100 to 200 miles or even higher when it comes to the large EV trucks. And in these cases, you really want to tailor your electric charging to how much time off the vehicle has. So if it's a bus, typically you can still charge them overnight, but you may need high power. If it's a truck, you want to minimize the amount of time that they stay in a given location. And so here you really want to only rely on DCFC. You'll never really be interested in L2s. So again, same mindset. You want to tailor the power that you're going to provide to your vehicle, depending on how much power in a given, how much energy in a given station they're going to need, and how long they can stay at any given site to charge. The other piece to consider is not only what's the characteristic of the car, but also what's the characteristics of our user. So you need to try to understand who are your drivers going to be, in addition to what car they drive and how long they're going to stay at your facility. And that's going to influence what type of chargers you will want to look for. For example, on the left here, we have shopping malls. So literally anyone can drive to your shopping mall to a parking lot and plug there. And people who do that, the expectation is that they come to do their shopping. So they stay maybe 1-2 hours, maybe a bit more, but not more than 4. And then they leave. So you're more likely to want to provide them with some level 2, but mostly DC fast chargers that match the 1 to 2 hour dwell time. And you want to make sure that the software that comes with the charger is equipped with payment. Example number 2 is the office, where your drivers are employees and visitors. In this case, you know that people will show up usually between 9 to 5 to charge. So you want mostly L2s, and you may want a couple of DCFCs as well to manage emergencies. And here your authentication needs really depend on your setting. Maybe you want the full payment platform with the app, like the public shopping mall, but maybe you're more interested into authentication either via email address, so that's the app, or RFID with your employee badge. And then last example on the right, multi-unit dwellings. Here you know that your drivers are your residents. Their cars are parked there most of the time, so 12 plus hours. And so you really only need L2 plugs, and the degree of authentication really depends on how you want to charge for that service. You could be plug and charge free for all if you cover EV charging in your rent, or you may want some degree of authentication that is similar to the two others. The last question is, how many do you need? And here, PowerFlex has really philosophy that more is better, and that's not just because it's self-serving, but really because we're really convinced that it's better for the users and better for the ultimate experience of having an electric vehicle. So here are a couple of examples. The first one is if you are in an office building and you don't have enough chargers in your parking lot, your employees are going to want to rotate their cars during the day, and that is disturbing. So that's a distraction, and then that results in a fair amount of time wasted. We estimate about 10 minutes to leave your office, walk to your car, change your car around, and come back to your office. And that's for two people: the people who came in the morning and plugged in the morning, and the people who plugged in the afternoon. And you can do a quick back of the envelope calculation of lost productivity, but very quickly, within a couple of months, you basically cover the cost of adding a new charger. So we say you might as well have enough chargers for all your employees rather than try to keep things reduced in size. Of course, adding more chargers results in more costs, but we'll see a bit later that you can really manage these additional costs in a way that makes sense. And same thing if you're a multi-unit dwelling, you don't want people to have to wake up at 2 a.m. to charge their car to ensure they can go to work in the morning. So really, you want as many chargers, again, in that case as possible, or you're quickly going to hear from your drivers that the solution is not satisfactory. And the last piece to that argument is that, as you certainly heard, the expectation is that there will be a lot more electric vehicles on the road in the next few years. The growth is expected to go from 2.5 million units in 2021 to 10 times that number in 2030. There are states like New York and California who are banning future sale of gas vehicles in the 2030s. So that will also increase the number of vehicles. And then all of the mainstream car manufacturers are making big commitments to electrifying their car offering. So all of that to say, the number of vehicles that are electric on your parking lot today are definitely not what will be in your parking lot in the next couple of years. And so you really want to be prepared for the future. So how many chargers do you actually need? It depends on the size of your parking structure, but in California, there are some certain rules and requirements that focus on saying 10% of EV spots, 10% of parking spots should have EV chargers, and as high as 20 to 25% of the spots should be EV ready, which means that you should have the infrastructure in place to quickly add an additional charger. And that infrastructure means electrical panel and conduit runs so that you can run wires from the electrical panel to the future EV spot. And in practice, as I said, the two rules of thumb are we recommend you be future ready because you will need more tomorrow than you need today. And then there are big economies of scale in installing a large number of chargers today rather than putting different phases of like 5 today, 5 tomorrow, 5 2 years from now, etc. And that comes from the fact that there are a lot of fixed costs in an installation project, such as permitting, design, And then all the mobilization around trenching, where you need equipment to come on site, dig a hole, run wire, and then cover that hole and resurface your parking lot. All those costs are pretty much fixed, and it doesn't matter whether you do 20 or 30, as long as you can all do it in a day or within a similar time frame. So we really recommend looking ahead and thinking how many chargers will you need in the future, and not just how many do you need today. And that brings us to the cost. So with that said, you still want to minimize your costs today, both for the installation and the operation. So if we look at cost comparison between level 2s and DC fast charger, level 2s cost between $2,000 and $5,000 depending on the model per unit, where our DC fast chargers are much more expensive. They're between $10,000 and $100,000, and you could even, if you look at the really fancy models, you could go even higher than that. And then all the other costs, which include labor, installation, permitting, all those things, they're in the $3,000 to $15,000 range for L2s, and they're in the $35,000 to $55,000 range typically for DC fast charger. So in total, you're looking at $5,000 to $20,000 per charger for installing a level 2, and $45,000 to $150,000 or more for a DC fast charger. That's for the installation cost. And the other piece to take into account is what is your energy cost to run them on a day-to-day basis going to be. And L2s can be managed in a way that keep your energy costs low. And we're going to cover that in a second. But for DC fast chargers, your demand charges are going to be high. And what that means is commercial electric bills have two axes of billing. One is the energy that you used, so how many kilowatt hours, just like a residential customer, but also what was your maximum power that you demanded at any given month, at any given time in the month. And the reason for that is even if you use 30 kilowatt on average throughout the month, if you have one moment where you ask for 100 kilowatt, for example, the grid needs to be built to accommodate that 100 kilowatt excessive power demand that you use, and making that capacity available is very expensive, so you're being charged for that. And demand charges can represent up to 60 or 70% of the electrical bill, so it's really important to manage those. And when you add DC fast chargers, especially in the 100 or 200 kilowatt range, you are going to naturally increase those demand charges. So you need to be mindful of that. And now let's look a bit more into what adaptive load management is. And adaptive load management is really critical to controlling both the installation and the operation cost. So if we take a standard approach without any load management, you want to install a 10 kilowatt EV charger, you're going to put a 50 amp breaker or 60 amp breaker on that charger. And if you want to install 5 of those chargers, you will want to install exactly the same thing 5 times. And that means that your maximum power that you will need to account for is going to be 5 times the max power of that charger. So in my example, 50 kilowatt. This works well for small sites, but it's not good for scaling. It's going to be very expensive. And then so you're basically paying for what you're putting there. It's not very optimized. The first level of optimization, which is what most of our competitors do, is circuit sharing or load management by infrastructure. And here the idea is that you're going to put 2 chargers on a single circuit or something similar. And what that means is that those 2 chargers will be able to share a single circuit, but those are only, you're optimizing at the circuit level and not at the electrical service level. So you're putting twice as many chargers as you could before, but that still limits you in terms of scale. And then you are limiting the amount of energy that your drivers can have at the same time. At PowerFlex, we have developed adaptive load management, which is a proprietary smart technology that really is as smart as you can be when it comes to EV charging. And that allows us to save up to 60% on the cost of installation, because we can install a lot more chargers on a given electrical infrastructure. And we can double, or sorry, we can install up to 4 times more chargers than the competitors on that infrastructure. So we have 2 ways of looking at it: either 4 times more chargers or savings of up to 60% on the installation side. And the other piece too is that this is done without compromising anything on the electrical safety, but also on the quality of the service that you're providing to your drivers. So if we look into more details, this is the example of unmanaged chargings, where you have here in that example 4 chargers, and when we have 4 cars who plug in, their energy use add up, and if you had a power limit that was not meant to accommodate for 4 chargers, you're going to be over it. Competitors, when they do either circuit sharing or other similar sorts of sharing, they do either equal share, which means that if you have a certain amount of power and you have 3 vehicles, you're going to divide that amount between these 3 vehicles up to the maximum of the charger. And if you have a 4th vehicle that comes in, then you're going to redivide. But the difficulty here is that as a result, if a driver comes and plugs into a 10 kilowatt charger, they may only get 5 kilowatt and not have a good way of controlling that, and they may not have a full battery at the end of the day. And this is even worse if you do first come, first serve, which some people do. Whereas with adaptive load management, as I said, it's as smart as it can be. We take into account the power limit of your site, the tariffs of electricity to make sure that your bill is really managed both from the demand charge, but also the cost of energy point of view. And then we take into account the needs of the chargers, so the needs of the driver, so that we ensure that cars get the energy they need in the time they need it, so that by the end of the day or whenever drivers come to pick up their car, they have a full battery. And as we said before, with this adaptive load management, you can save up to 60% on your installation costs, and you can install 4 times the same amount of chargers that you would otherwise without adaptive load management. So when we say you need more chargers than you think or that you need today, we actually provide you the tools to make sure that adding those chargers is not a burden, financially, and that you can actually achieve installing all those chargers for the same cost as you will have install less chargers with the competitors. So let's look at a few case studies just to give you an example. Our biggest customer is Los Angeles International Airport, ALX. We have 1,200 and plus chargers installed. We have 16 DC fast chargers. And that is because most people who park in an airport, they stay there for multiple days. So you don't really need DC fast chargers, but some people may just need drop someone and then need an extra charge, and so that's why you have the DC fast chargers. That number of chargers tells you, like, when we say we can manage in a smart way, we can manage in a smart way at scale with adaptive load management, because you managing that amount of charger is not trivial, and minimizing operating costs and electricity cost is not easy, but we do it. Another example here is an apartment building where you have only level 2 chargers. Workplace, where, as I said, you have mostly L2 chargers and a few DC fast chargers for emergencies. And then we also work with the County of Los Angeles, which has over 1,000 chargers deployed at different sites, which are mostly government office buildings. And then we have a few public DC fast chargers as well. So those are examples of what type of customers we work with. And the idea is really to show you as well that the power of adaptive load management enables us to install a lot of chargers that are going to meet the high number of cars that are going to be on the roads tomorrow, and not just 2 or 4 at any given parking site. So with all that, I want to thank you for your attention, and I'm ready to take some questions. I see that there are some in the chat.
Yes, thank you, Balthazar, and thank you everyone for joining us and for adding your questions. We have a lot, so we'll try to get through as many as possible. We'll start off with the first question. Is there a difference in durability or lifespan between L2s and DC fast chargers?
I would say the biggest difference is that DC fast chargers, if there is a piece that breaks, you can replace it, whereas level 2 chargers, if something breaks and it's not under warranty, you will want to replace the charger. But typically, manufacturers provide the same the same warranty length, which is between 2 and 5 years, depending on the manufacturer. So the short answer is probably not on paper, but in practice, you can certainly achieve longer lifetime with your DC fast charger thanks to replacing parts that break over time than your L2.
Another question, in the future, do you anticipate a greater need for L2 or DC fast chargers? Do you see a trend or the industry leaning in one way or the other?
That's a good question as well. The answer is both. We're going to need both DC fast chargers and level 2s. And what I hope I conveyed in today's presentation is that what you'll need really depends on your use case and the situation of the driver. Right now, there is a lot of focus on deploying DC fast chargers along highway corridors, because that's what's going to enable electric vehicles to really be able to achieve the same type of range and driving habits that people have with gas cars. But on the other hand, in the day-to-day, 95% of your travel needs are going to be met by L2s, simply because you don't typically take a 200-mile trip every day. And if you're below 200 miles, if you're in the more like 40 to 50 miles per day range in terms of use of your car, L2 is perfectly fine.
The next question, as more EV charging is added, how will this affect the existing grid?
That's a very good question. It's concerning. So the grid right now is really strained, both from the addition of new capacity that's distributed, like renewable energy on rooftops, but also EVs represent a big load that's new. If you install an EV charger in your home, typically this is going to increase your energy use by about 30%. And depending on how much you used before, that could really like spike the power demand that you'll have on your home. So there is a real concern. I would say a lot of people are looking into it, and the answer to solving the grid is offering more flexibility and being smarter around how we use the grid, both with renewable energy and EV chargers. And once again, that's something that PowerFlex we're very mindful of, because we are on the two sides of this equation with the renewable energy and the EV chargers, and also our mother company is EDF Renewables, and ultimately that's EDF in France, which is a big national electricity provider. So like the grid is grid concerns are in our DNA in a way, and that's why we care. Like that's why adaptive load management and smarts and flexibility around energy is really what we focus on.
Right, we call ALM the grid-friendly charging technology. So
yes,
we are very aware of this. I guess our next question is, you mentioned integration with solar and storage technologies. Can you talk more about how EVs work together with them, if it's possible to add one or the other later, and if it's better integrated with like L2s versus DC fast chargers? I know that was a lot, so if you need me to repeat, let me know.
No, that's okay. Solar and storage definitely, so solar definitely allows you to reduce the amount of energy that you capture from the grid. The nice thing with integrating solar with EV charging is that if you have users who park there during the day, you can really feed that energy straight into their car. So you have cleaner vehicles overall, because it's 100% sun powered. And also, you know that your energy is put straight, that you're producing with your EV charger panel is self-consumed. And that's always how you maximize the value of your solar panels. Otherwise, if you don't use the power that you produce, you export it to the grid, you get compensated for that, but that's less interesting than just using what you produce. And storage, like stationary batteries for storage, help you do a few things, but in particular, they help you optimize your self-consumption. So that's one thing. And they also help you do peak shaving in terms of making sure that you don't have spikes of power use, as I mentioned earlier. So the short answer is, the more assets you have, the more opportunities you have for optimization. And but having at least one to start with is always good, and you can choose which one makes more sense for you.
And I think another part of that question was like, is it better for, would it matter if it's fast charger or L2 in that case with integration?
That yeah, so fast chargers are going to have higher power demand, and you can limit those, but then you lose the value of having a fast charger. So in that case, fast charger and a battery can be a good idea. Otherwise, L2s really provide you a lot of flexibility when it comes to how you use them.
Great. Next question, how does PowerFlex source its EV charging hardware?
We work with a variety of manufacturers. We like to have a two-tiered approach. One is where we curate a portfolio of chargers that we know inside out, and in some cases we've designed ourselves. And those are the chargers we recommend whenever we sell projects. But we're also able to integrate our software platform with any charger on the market that follows the OCPP protocol, which is a standard communication protocol between chargers and the cloud. And so if you have existing chargers on your site and you want to add PowerFlex, we can very well integrate our platform with those chargers that are already on site, so that you can manage through PowerFlex your overall installation, so your old chargers and your new chargers.
Thank you. And this question seems to come from somebody who already has an EV. And his question is, if you frequently use a fast charger, does it impact your battery life? Like, are there maybe any negatives?
I am not the best person to answer that. I would say car manufacturers, the short answer is probably yes, but it's secondary in the sense that car manufacturers and battery manufacturers have become really smart at making sure that the way their batteries are used is good for their lifetimes and optimizes their lifetime. So typically what you'll see is that there will be even if you take a small car and you plug it to a 200 kilowatt DC fast charger, the car will never accept 200 kilowatt. It will more likely be around 50. And that's simply what the manufacturer says is the max speed of charge for the batteries to remain to maintain their integrity. What we've seen is that what's most important in terms of lifetime of the battery is your state of charge. So you want to keep your battery typically between 20 and 80%. If you go above 80%, you really pack a lot of electrons in your battery, and over the long term, that quickens the degradation, and even more so if you go below 20% as well, because you're really trying to pull out of the electrodes as possible, and that creates material deformation within the battery. So my short answer to that is, don't fret if you have to use a DCFC. That's not a big deal, but make sure that you stay within those 20 to 80% bound when it comes to state of charge.
Great, and I think we have time for one last question, which is, can you add PowerFlex's adaptive load management to existing charger installations?
Sorry, can you repeat that question?
Can you add PowerFlex's adaptive load management, like software side of things, to an existing charger installation?
Yes, very much so. We're happy to work with you to do that. As I said, we can talk with any charger that is OCPP compliant, and that's a norm in the industry. So most likely your charger is compliant, assuming that the brand allows us to work with them. So for example, charge points, typically they are not open to letting us control their chargers.
Great. Well, thank you, Balthazar, and thank you to all our attendees for joining and for asking many, many wonderful questions. I know that we haven't been able to answer all of them, so please feel free to contact us, and we will make sure to have someone have a conversation with you to learn more. And with that, I think we're going to close our time here today. For those of you who are wondering, we have recorded this, and we will also be sharing the deck afterwards. So if you want to refer to this again or share it around internally with your teams, you will be able to do so. And as a little teaser for next month, we will have another webinar that's covering safety during installations. So we hope that we'll see you then too. Thank you so much and have a great day.
Thank you very much. Thank you, Emily.
Bye.